welcome to True Projects. In this video, we are going to discuss about evaluating machine learning techniques for detecting offensive and hate speech in South African tweets. Introduction. Tweeters have witnessed a surge in inflammatory and racially charged language in South Africa. English serves as prevalent language in that country. The unique nature of South African tweets and the intersections among offensive, hate, and free speech necessitate specialized English datasets and approaches for detecting such speech. While the algorithms are commonly applied to identifying offensive and hate speech in various English contexts, machine learning techniques are now being utilized to recognize inappropriate and hateful communication. This involves extracting and scrutinizing syntactic features, character engrams, word engrams, and negative sentiment. Gradient boosting, ensemble methods, and multi-tier metadata, meta-learning models involving support vector machine, logistic regression, and ensemble learning are employed for analysis. Objective. The project's primary goal is to assess the effectiveness of machine learning algorithms in detecting offensive, hate, and free speech within social media text. English tweets are used as substitute for South African content. The process involves pre-processing data, addressing class imbalance with SMOT, and training diverse models such as SVM, logistic regression, gradient boosting, random forest, weighted voting, and meta-learning. Evaluation metrics encompass accuracy, precision, recall, and F1 score. Through visualization, the top performing model is determined. These are the requirements for execution of the project. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. In software requirements, Python IDLE of 3.7 version is required. Coming to algorithms used, first one is support vector machine. It is a binary classification algorithm that aims to find a hyperplane that best separates different classes. The optimized SVM is likely refers to the use of optimized hyperparameters or kernel functions to improve classification performance. Second one is logistic regression, a linear classification algorithm that models the probability of data points belonging to a particular class. It is commonly used for binary classification tasks. Third one is gradient boosting. Gradient boosting is an ensembling method that combines multiple weak learners, usually decision trees, to create a strong classifier. It builds models sequentially, with each model correcting the errors of the previous ones. Fourth one is random forest. Random forest is another ensembling learning technique that creates a multitude of decision trees and combines their predictions to produce a final result. It helps to reduce overfitting and improve accuracy. Fifth one is weighted voting classifier, a machine learning model that aggregates the predictions of multiple classifiers, each having a different weight. The final prediction is determined by the majority voting of the weighted predictions. Sixth one is meta-learning stack classifier, a meta-learning technique that combines predictions from multiple base level models. The meta model learns to combine the predictions of these base models to enhance overall performance. Coming to methodology, we have designed these modules for execution of the project. First one is upload tweets dataset. This module involves loading the dataset containing the tweets, which could typically be in CSV format or text file format. Second one is pre-processed dataset and TF-IDF pre-processing. In this module, the raw text data of the tweets is pre-processed to make it suitable for machine learning analysis. Pre-processing steps might include removing special characters, converting text into lowercase, removing stop words, and applying stemming or lemmatization. After pre-processing, the text data is transformed into numerical features using TF-IDF, which is term frequency inverse document frequency representation. This technique converts text into format that machine learning algorithms can work with. Third one is run SVM algorithm. This module involves training and evaluating a support vector machine classifier on the pre-processed and TF-IDF transformed dataset. The classifier is trained on classified tweets into specific classes, which are hate, offensive, and free speech. The accuracy, precision, recall, and F-score of the SVM classifier is computed and presented as output. Similarly, we will run logistic regression algorithm, gradient boosting algorithm, weighted voting algorithm, and meta-learning algorithm. Next one is accuracy graph. This module generates a graph where the x-axis represents the name of the algorithms used and the y-axis represents corresponding accuracy achieved by each algorithm. This visualization helps in comparing the accuracy of different algorithms. Ninth one is precision, recall, and F-score graph. Similar to the accuracy, this module generates a graph showcasing the precision, recall, and F-score of each algorithm. This visualization provides insights into the algorithm performance in terms of correctly classifying different classes. 10th one is predicting hate, offensive, and free speech. This module is designed for making predictions on new or test dataset using trained machine learning models. Users can upload a test dataset containing tweets for which they want to predict the class, which is hate, offensive, or free speech. For execution of the project, first we need to open the code folder. This is the code folder of the project, and this is the dataset folder. This is the train dataset. These are the tweets of the data. For these tweets, we will be training all the algorithms, and this is the test data. For this data, we will be predicting which is hate tweet or offensive tweet or free tweet. And these are the features of the data. And this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So we need to double click on it for execution. And this is the Python main code file. Now we will double click on run.bat file for execution. This is the graphical user interface of the project. With this, we will be interacting with the program. And this is created by using Tkinter library. So first we need to upload the tweets dataset. For that we need to click on this upload tweets dataset button. So we will select dataset and click on open. Here it is confirmed that tweets dataset is loaded. Now we need to click on pre-processed dataset and TF-IDF processing for converting the data into vector format. So here data is pre-processed and converted into TF-IDF processing. Here we can see that total tweets are 4,869 and total unique words or TF-IDF features are 2,128 features. Here we have 0 label for hate speech and 1 label for offensive language and 2 for free speech. And the dataset is split it into train and test, where training consists of 80% and test consists of 20%. In training we have 3,895 records, in test we have 974 records. Now we need to click on the button run SVM algorithm. All the algorithms which we are going to perform, first they will be trained on this training data and then they will be predicted on this testing data. Now we'll click on run SVM algorithm. So here we got SVM precision, recall, F measure and accuracy scores of SVM algorithm. Now we will click on the button run logistic regression algorithm. Here we got precision, recall, F measure and accuracy scores of logistic regression algorithm. Now we'll click on the button run gradient boosting algorithm. Here we got gradient boosting precision, recall, F measure and accuracy scores. Now we'll click on the button run random forest algorithm. So here we got random forest precision, recall, F measure and accuracy scores. Now we'll click on run weighted voting algorithm. Here we got weighted voting precision, accuracy, precision, recall and F measure scores. Now we need to click on the button run meta learning algorithm. Here we got meta learning precision, recall, F measure and accuracy scores. Now we'll click on the button accuracy graph to compare all the accuracy scores of all the algorithms. So here on x-axis we have algorithm names and on y-axis we have accuracy scores. For meta-learning accuracy and logistic regression accuracy is higher than all other accuracies. So we'll close this graph. Now we'll click on the button precision, recall and F-score graph. Similarly, in this graph also we have on x-axis all the algorithm names and on y-axis we have precision, recall and accuracy scores. Now we'll click on the button predict hate or offensive or free speech to detect the speech. So we'll upload test data and click on open. So here for this particular tweet it has predicted as offensive speech, and for this speech it is predicted as hate speech, and for this tweet it is predicted as free speech. Now we'll close this GUI. Conclusion. The project where we assessed a range of machine learning algorithms to categorize offensive, hate and free speech in social media text by pre-processing the dataset and rectifying class imbalance through SMOT, we have discovered that meta-learning stack classifier consistently excelled, attaining the highest accuracy. This indicates that amalgamating predictions from base level models enhances classification performance. Logistic regression also displayed robust accuracy. The project emphasizes the importance of algorithm choice, pre-processing and managing class imbalance to precisely classify sensitive speech forms in social media data.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.